The telescopes of Galileo are iconic, not just in telescopic astronomy, but to physics and the enterprise and ambition of science in general. In this video, we're going to take a closer look at Galileo's telescope. We're going to be using this replica, which I actually made this about 6 years ago, and it's actually an amalgamation of the specification and features of the two surviving Galilean telescopes held by the History of Science Museum in Florence. It's a very detailed replica, and we'll look at it in a bit more detail later on. But the main point of this video is going to be to give you a chance to actually look through this telescope so that we are in a better position, and then we're going to compare it with views through other typically modern telescopes, so that we can actually ring the changes between the quality of view that we get through Galileo's telescope and what we're more familiar with today. Now, by doing this, we hope to throw some light on some of the difficulties that Galileo actually had in his enterprise of convincing people that of the veracity of the views he was gaining through his telescope, and perhaps by doing this we might be able to see and illustrate some of the difficulties he was actually having. The development of the telescope in the early part of the 17th century probably was going to favour almost anyone who pointed it at the night sky with fame. And it's important not to see Galileo, I think, as someone who simply jumped on the bandwagon of the telescope. He really did do a lot to develop the telescope, to improve its design. He made systematic inquiries of the night sky, and he was also instrumental in making developments of both the telescope, the way the telescope is used, and the things that can be seen with the telescope. And obviously is an extremely important figure throughout the 17th century. Equipped with what by today's standards was a very basic telescope, in just a few years Galileo made some of telescopic astronomy's landmark discoveries. He's one of the first people to see and correctly describe the craters and mountains of the moon. He described the 4 major moons of Jupiter, the Galilean moons as we call them. In fact, Galileo dedicated the moons to a rich and powerful member of the Medici family, and for well over a century the moons of Jupiter were known as the Medicean planets. Galileo also correctly described the phases of Venus and was the first to observe sunspots and to correctly identify them as phenomena associated with the surface of the sun. Although the Galilean telescope design suffers from a sharply restricted field of view, the telescope does produce an erect or corrected eyepiece view without additional optics. In contrast, the Keplerian telescope design provides a greatly increased field of view, but produces an inverted or upside down eyepiece view, and requires additional lenses to correct the view. Before we get down to the main event of actually looking through Galileo's telescope, I just want to show you the telescope in a little bit more detail, because it has some fairly unusual features in comparison with, well, frankly, almost any other optic that you're likely to come across. It's mostly of wood construction, obviously, and glass with the lenses. The tube here is actually split lengthwise and is held together with these copper wires. I don't know if you can come in a little bit closer and actually see that. The lens head here is wooden and turned, and I think you can see the objective at the front here. It's a single element objective. It's a plano-convex lens, and it is actually larger than the aperture that you can see here to actually improve the performance of the optic, both in terms of reducing the chromatic aberration and error in terms of misplacing some of the light at the business end here. The aperture has been restricted to just 15 millimeters. Now, that makes this a very unusual telescope. Just 15 millimeters aperture and over 900 millimeters focal length. You're not going to find too many telescopes that look like that around today, I don't think. At the other end, at the eye end, the eyepiece here, it's actually in a tube that actually moves backwards and forwards to achieve focus. And inside there, again, is a single element lens, this time a plano-concave element. And again, the size of it has been restricted, not too alarmingly this time, down to around about 8 millimeters, as far as I can remember. Remember, this is a replica of the two existent Galilean telescopes held by the Science Museum, Museum of Science in Florence, but it's a little bit too fragile for me to take it apart and actually show you any of the parts there. So what I'm going to do very quickly is build you a postal tube telescope in just a few moments. So I'm not going to spend too much time on this, but we are going to look through this telescope as well. So I'm going to just build this in front of you very quickly, and it's going to enable me to kind of tell you a little bit more about Galileo's scope at the same time. So here's our tube. That corresponds to the tube, obviously, of Galileo's. Here's the lens. Now, you can't see it, but this is actually a biconvex lens, so it's actually curved on both sides, which is far more typical of a modern element. Normally, in a good quality modern telescope, of course, we would have two elements at the front end. We'd have a compound objective rather than this single element. I'm just going to put that on a foam pad there. This is the other piece of glass that we're going to use in the telescope, and you can see, I think if you come in a little bit closer there, you can actually see that that's a plano convex lens. Convex in the sense that it bellies out on this side, and is plano, that's the flat part on the rear of the element. Now, it's all very simply done. I've cut a little strip off the postal tube, and I've actually just cut through it and made it a little bit smaller, and I'm going to put that inside the tube to act as a lens support, and we're just going to pop the lens in the front there. Don't do this at home, kiddies, but I can do this because I'm an expert. Just give the lens a quick polish because I've been handling it on the tail of my shirt there. Drop that in onto the inside, and then I've just got the end of the postal tube and I've cut the inside of it out, and there you go, there's the objective end of the telescope ready to go. For an eyepiece holder, I've actually got a couple of plastic cores from a tape holder. Can't remember what the tape was for, but they're just something I found laying around basically in the rubbish, and the lens just drops on the back there and sits into place, and I've cut the end out of a old dust cap, and I'm just going to put that over the end of that to hold the eyepiece, the lens in position, and bingo, we've got a telescope. And it's more or less the same as Galileo's instrument, although of course we've used a modern machine ground lens at the front here and at the back end, and it's significantly shorter focal length. Galileo's telescope produces, and our replica produces, a magnification a little over 20 times. The telescope I've just built here is going to it's going to magnify around about 5 times. And in a moment we're going to show you what the world looks like through these and another telescope as well. But first of all, just take another quick look at the Galileo scope again, and just define an important difference about Galileo's scope compared with our postal tube telescope here. One of the very important features of Galileo's scope is the lens that he actually used in the eyepiece, and it's this design of eyepiece that really created a lot of problems in the optical performance of this telescope. Unlike the eyepiece we saw on the postal tube, which was planar convex, this one is planar concave. So we have a flat side, and we also have then a dished side. You can probably see that in a bit more detail if it's actually difficult to show you on camera, but if I drop a ball bearing onto the surface there, you can actually see as I rock that backwards and forwards that ball bearing is very nicely held by that dish-shaped lens there. Now, that eyepiece, that configuration that Galileo used, which we still call Galilean, by the way, so there are still Galilean instruments around. You tend to find that they're restricted these days to opera glasses, or possibly children's binoculars. Sometimes have a Galilean design with no prisms in them. And again, they use that same plano-concave optic in the eyepiece. And it's one of the reasons why opera glasses don't actually give you a very nice view, and with a very limited field of view, for basically because of the same reasons that Galileo's telescope didn't. That so-called negative lens, that's that concave eyepiece design, really does make the optical system very, very narrow, very, very narrow field of view. The postal tube telescope actually uses a system that we refer to as Keplerian. Now, the reason why we don't call modern telescopes, modern refractors, Keplerian in design basically is because nobody makes anything like this anymore. So we really don't need the distinctions anymore. But the Keplerian design is so named by the 17th century mathematician Johannes Kepler, who shortly after Galileo made his telescopes was able to make some improvements in the design of the refracting telescope, creating a lot more field of view by using a convex eyepiece system rather than that's a positive convex lens rather than the negative lens used by Galileo. And you're going to see the difference that makes when we actually look through this telescope a bit later on. Galileo made his first telescopes in the summer of 1609. By the autumn of that year, he had embarked on the world's first serious telescopic study of the night sky, basically an enterprise that is still going on today. We're going to go outside now and take a look through these telescopes. And first off, we're going to start with the postal tube instrument and get you a look through that. Then we're going to look through a modern 66mm aperture refractor. And then we're going to move on and show you the view through Galileo's telescope. Let's do that now.